Okay, ma'am. So next concept, the last concept in capacitors is dielectrics, ma'am. Okay. So what is meant by dielectric? Dielectric, any insulator is called a dielectric. Any insulator which does not conduct electricity, that I can call it as a dielectric. So what is the difference between insulator and conductor, ma'am? Difference between insulator and conductor is what? చెప్పండి చెప్పండి ఇది కూడా చెప్పలేకపోతే ఎట్లా? సో కండక్టర్ హ్యాస్ ఫ్రీ ఎలక్ట్రాన్స్ నమ్మా. Conductor has free electrons, whereas insulator does not have any free electrons. So these free electrons, they are very loosely bound to the valency shell of the atom. Are you able to understand? So by taking energy from atmosphere also, they are released into the metal, that is the core of the metal, and they are ready to travel throughout the volume of the metal, free electrons. But whereas the electrons which are present in insulator, they are very tightly bound, so they cannot come out of the atom. That is the difference between insulator and conductor. Are you able to understand? So therefore this insulator also I can call it as a dielectric, and this dielectric I can divide into two types. One is polar dielectric and the second one is called as non-polar dielectric. Polar dielectric means what? Naturally the center of positive charge and center of negative charge, they do not coincide. Okay, say for example if I take any atom or a molecule, so this is the center of nucleus, this is the nucleus, and around the nucleus electrons will be rotating like this. This is the structure, basically. So at the center what is present? Positive charge is present, and surrounding this one what is present? Negative charges are present, and all the center of negative charges, if it is present on nucleus itself, center of negative charges also will be there. Center means what? Center of mass. Center of mass of all the negative charges, if it is present on positive charge itself, then there is no problem. Are you able to understand? But in some of the molecules what happens is, center of positive charge will be somewhere here and center of negative charge will be somewhere here. So this behaves like a center of negative charge. Are you able to understand? It means this molecule, it is behaving like a dielectric. Dielectric means what? At one center positive charges are concentrated, at another center negative charges are concentrated. So it is behaving like a dielectric. Dielectric means what, ma? So insulator, or you can call it as a polar dielectric. Are you able to understand? So if a center of positive charge and negative charge do not coincide, then it behaves like a dipole. It behaves like what, ma? Dipole. What is meant by dipole? Already we have studied, no? What is meant by dipole? Dipole ante చెప్పండి. Dipole means two equal and opposite charges separated by small distance. This is called as a dipole. Do you remember? Dipole పైన అన్ని క్యాలిక్యులేషన్స్ కూడా చేసినాం కదా, గుర్తుందా లేదా? So therefore this is the positive charge center and this is the negative charge center, and they are separated by 2a distance. Okay, so this behaves like what? This behaves like a natural polar dipole. Are you able to understand? And if it is an insulator, it is called as polar dielectric, because dielectric is nothing but insulator. So this is a polar dielectric, where positive charge and negative charge, they are not present at the same position, but they are separated by some distance. But what about non-polar dielectric? Non-polar dielectric means center of positive charge and negative charge will be at the same point. That is called as a polar dielectric. Non-polar dielectric. Are you able to understand, ma? Okay. Now let us see what happens if I place this dielectric in an electric field. Okay, ma? So placing dielectric dielectric means insulator, ma, don't be confused. Placing dielectric in electric field. Okay, see, ma, for example, consider this is a metal, piece of metal. Okay, and if I place this metal in electric field, can you say what happens? If I place a metal in electric field, what happens? So if I place this one in electric field, okay ma, so this is the direction of electric field, then what happens? All the negative charges, that is electrons which are present in this metal, they come and deposit at one end, no ma? Clear, no? That's what negative charges behave, no ma? Negative charges will experience force in which direction? In the direction, opposite direction to the direction of electric field. So this side completely it will take a negative charge. So automatically on this side, we see all the positive charges will be deposited, no? Are you able to understand, no? So therefore, inside this metal, there will be an induced electric field, which is in opposite direction to the direction of applied electric field. Already we have studied all this, no? What is this electric field? This is external electric field, the electric field which we have applied. And what is this electric field? This is the induced electric field. Clear, no ma? Which is in opposite direction. Mudassir Khan, Zamin Pochine, Suno. Clear, no ma? So therefore, this electric field and this electric field, they get cancelled with each other, no? So therefore, finally what happens? Finally, I can see if this is the metal, clear, no ma? Electric lines will be just traveling like this. But it is as if these electric lines, they are not entering the metal. Ila behave chestayi kada? It appears as if electric lines, they are not at all entering the metal. But actually they are entering. But what is happening? So the field which is entering and the induced field, they are getting cancelled with each other. So therefore, what is the net electric field inside this metal? Net electric field will be how much, ma? It will be 0. This is what we have studied, no? Clear, no? Now instead of this metallic conductor, if I place an insulator, then what happens? Let us see. Clear, no ma? So, and insulators are how many types? Two types are there, no ma? One is polar dielectric and the second one is non-polar dielectric. Now see. So therefore, this is a insulator, ma? Insulator. Okay. And I am placing this one in electric field. Then what happens? So consider this is the external electric field which we have applied. Okay. Then what happens is the molecules which are present in the insulator, whether it is polar dielectric or whether it is non-polar dielectric. Adi a type of dielectric aina kane. If it is polar or non-polar, whatever it may be, nothing will happen. Okay, ma? So this molecule, what is this molecule? This is the molecule or atom of dielectric or insulator. Okay. So this atom itself, it will take this kind of shape. Okay. Previously atom was like this. Dielectric. Dielectric. Are you able to understand, ma? Previously atom was like this, but if I place this one inside electric field, it will get distorted, ma, and it will take this kind of shape. Are you able to understand? Previously, the positive charge and negative charge may be coinciding, may not be coinciding, depending on whether it is polar dielectric or non-polar dielectric. But when you place it inside electric field, immediately what happens is it will take this kind of shape. Are you able to understand? It means every molecule which is present inside this insulator, it will distort like this. Negative, positive. So negative, positive. Negative, positive. Negative, positive. So like this, a distortion will happen. Okay, ma? So if a distortion is happening, what is the meaning of this? Can you say? So this is positive and this is negative, no ma? So now positive charge and negative charge, they are not coinciding with each other. So therefore, a very small amount of electric field, which is called as induced electric field, will start developing in this direction. Okay? Have you understood what is the reason of this induced field, ma? Because positive and negative, now they are not coinciding, no? They are separated by some distance. It means it is behaving like a dipole. And what is the direction of electric field because of dipole? Positive to negative. That is the direction of induced electric field, no? Okay? But if you see this induced electric field is very, very, very small when compared to applied electric field. But in the case of conductor, what is happening? External field and induced field, they were equal and opposite. So that's why they were getting cancelled with each other. But here the problem is that E induced is smaller than E external applied field. Okay, ma? Its magnitude is very less. Okay. So if induced field is less than external electric field, now can you say what happens? ఇప్పుడు ఏం జరుగుతుంది చెప్పండి. Anybody? Okay. So the molecules of insulator get distorted. Okay ma? And a dipole moment is created in each molecule or atom, anything you can take. Okay ma? So an induced electric field develops in opposite direction to external electric field. Okay, but E induced is smaller than E external. Okay, previously in the case of metal, induced electric field and external electric field, they were equal and opposite, so they were getting cancelled. But here induced electric field is lesser when compared to external electric field. Now what happens? Adi question. ఇప్పుడు ఏం జరుగుతుంది చెప్పండి. ఆలోచించండి. Now what happens? Now what happens is, okay, Sima. So these two electric fields, they are in opposite direction. No? External electric field is in which direction? E external is in this direction. Induced electric field is in which direction? Induced electric field is in this direction. Clear, no? But external electric field is very large. Induced electric field is smaller. So therefore what happens? Up to this much amount, the electric fields will get cancelled with each other. But this much amount is still remaining, no? So what do you understand? The electric field which is present inside this insulator, it reduces. Are you able to understand? Now the final field which is present inside the insulator, it is lesser when compared to external electric field. Okay. So therefore how can I draw the diagram of this one? Diagram I can draw like this. Clear, no ma? So this is a dielectric. Okay. Now I can say that all the electric lines does not pass, but only few lines will pass. Are you able to understand, ma? I can draw the diagram like this, no? What is the meaning of this diagram? So there are many electric lines which are trying to enter, but out of them only few lines are able to enter. What is the meaning of it? It means that strength of electric field inside the dielectric has reduced. That is the meaning of this one. Are you able to understand, ma? So here how much will be the electric field? Here electric field will be E naught, external electric field, E external. Okay. But here the electric field inside dielectric, net electric field will be how much? It will be E naught divided by K. Okay. It means electric field has reduced by how many times, ma? K times. And what is meant by K here? Dielectric constant of this insulator. Okay, ma? So therefore K is called what here? K is called as dielectric constant. Okay, ma? Or I can say, what is the note point I have to write? In an insulator, the strength of electric field reduces by K times. Are you able to understand, ma, what is happening? Why electric field strength is reducing, you have understood, no? అసలు ఎందుకు తగ్గుతుందో అర్థమవుతుంది కదా. Because some of the induced electric field cancels the external electric field and electric field reduces. How many times it reduces? It reduces by K times. And what is meant by K? K is called as dielectric constant of this material. Is it clear? That's it. Make a note up to here. Okay, ma? Now see. See, ma, here what we are doing is, I am introducing a conductor, ma, in between the plates of this capacitor. Okay? So this is a positive plate and this is a negative plate. So in between these two plates, I am introducing a conductor. What is the thickness of the conductor? T. And total distance between the plates is D. Are you able to understand? Now already we studied that electric field cannot enter into conductor, no, ma? Or in another sense we can say, total electric field inside the conductor will be how much? It will be 0. Okay? So therefore, inside this conductor, net electric field is how much? Net electric field will be 0. There is no electric field. Now, how can I calculate potential difference between the plates of capacitor? Potential difference between plates of capacitor. Okay? See, ma. Potential difference V is nothing but E into D, no, ma? This is the formula, no? E is equals to V by D. So therefore V is equals to E into D. This is one formula of potential difference. But if you see here, electric field is present in how much length? D is called length only, no? Distance only, no? So electric field is present in how much distance between two plates of capacitor? Huh? D minus T. So therefore I will write V is equals to epsilon E naught into D minus T. Now can you say why I have written D minus T, ma? Suppose. Huh? Because in this region there is no electric field, no? In this thickness of this conductor there is no electric field. Electric field is present only in this much region and this much region. Clear, no? So this distance and this distance, how can I calculate? From total distance D, if you remove T value, then I will get remaining distance, no? I want that region where electric field is present. Electric field is present only in this region and in this region. So how can I add these two? From total distance D, you remove T value. Then I will get remaining distance. So therefore V is equals to E naught into D minus T. E naught is the field which is present between the plates of the capacitor. E naught. Okay. Now what is the formula? Formula is C is equals to Q by V. This is the equation of capacitance, no? C is equals to Q by V. So Q divided by V, how I can write? I can write E naught into D minus T. I can write like this. Okay. Now electric field between the plates of the capacitor. What is the formula? Do you remember? Electric field in between the plates of the capacitor. Sigma by epsilon naught. Gurtundi kada? Sigma by epsilon naught. So electric field between the plates of the capacitor. Sigma is Q by A, no? So Q by A into epsilon naught. Gurtuna ivanni? What is sigma? Surface charge density. Surface charge density is nothing but charge per unit area multiplied by electric field. Understood, no? So now take this value and substitute here. So therefore C is equals to Q divided by Q by A epsilon naught multiplied by D minus T. Okay. So Q and Q get cancelled. So epsilon naught A divided by D minus T. So this is the equation to calculate capacitance of capacitor when I place a conductor. And what is the thickness of the conductor, ma? Thickness of the conductor is T. Understood, no? Even arthaminda? Derivations are also important, ma? So observe thickness. Now see, ma. So if you observe this equation, C is equals to epsilon naught A by D minus T, what do you understand? Capacitance has increased or decreased? Capacitance periginda tagginda? Huh? Decreased. How can you say? Chappandi. Increased. Endukala? Denominator reduced, no, ma? Previously, without any conductor, what is the capacitance? C is equals to epsilon naught A by D, no? This is the equation of a parallel plate capacitor. But when I introduced this conductor, it has become D minus T. Okay? It means what happens to denominator? Denominator reduced. Denominator reduced means total value increases. It means if you place a conductor What happens to capacitance? Capacitance increases. This is the point which you should understand. Okay, so write down. So what I write is, okay, so when conductor is introduced, okay ma, when conductor is introduced, capacitance increases. Capacitance increases. This is the note point which you should remember. Okay, because denominator has reduced, so total capacitance increases. Okay, now I will write one case. Case is that if conductor completely fills the gap, between plates of capacitor. Now can you say what happens? Cheppandi ippudu. D minus D 0 అవుతాయి total capacitance infinity out. That's it. Okay ma. See ma, previously what we have taken previously, only this much part is covered by the conductor, no? Okay, so conductor was present only up to this region. Now what I am doing, I am taking the plates of the capacitor and completely filling the gap in the plates with the help of conductor. Okay, so it means that D has become equal to T, no? Or T has become equal to D. T means what? Thickness of the conductor. Thickness of the conductor is nothing but equal to D. So therefore, how can I write the equation there? Epsilon naught A divided by D minus D. So how much it will be? It will be infinite. So infinite means what? Infinite means capacitance will increase to very, very, very large value. Theoretically. Practically, it is not possible to make a capacitance of any body to be infinite, but theoretically, capacitance will become very large. That is the meaning of this. Clear, Nama? So therefore, what is the note point I have to write? Note point is that theoretically, capacitance becomes very large. Capacitance becomes very large. So if capacitance becomes very large, I can store a lot of charge, no? What is meant by capacitance? Ability to store charge. That's the capacitance. So if capacitance becomes infinite, it means I can store infinite amount of charge, which is not practical. Theoretically, it is correct. Understood, Dhamma? That's it. Write down. సో ఈ ఈక్వేషన్స్లో డెరివేషన్స్ కూడా మనం చూడాలి. ఓకే, సిమా ఒక్క నిమిషం ఉండండి. సి నవ్ ఇన్ ద సెకండ్ కండిషన్ we are introducing a dielectric. What is meant by dielectric? Already we have studied, no? When you place a dielectric, what happens to the electric field inside the dielectric? It reduces by k times. Whereas in the remaining gap, that electric field is E only. E or E not anything. Are you able to understand? Now can you say, how can I calculate a total potential difference between the plates of this capacitor? Potential difference, how can I calculate? Previously, how we calculated? Potential difference is nothing but E into D, no? Now can you say, how can I calculate? Potential difference is a scalar quantity. Potential difference is what kind of quantity? Scalar quantity. Potential difference ante basic definition gurtunda? Balaji. Potential difference ante basic definition emiti? Work done per unit charge kada. Clear nama? Work done is a scalar quantity, no? So potential difference is also a scalar quantity. It means you just add all the potentials, you will get the total potential difference. Okay ma? See ma, in between the gaps, potential difference is how much? I can say E multiplied by E naught multiplied by D minus T. This much, no ma? Gaps are how much? Total distance D minus T. Then you will get the gaps. Okay? So this is the amount of potential difference in the gaps. Now what is the potential difference existing inside the dielectric? That is E naught by K multiplied by, what is the distance? Distance is T only, no? T. So this is how I can calculate the total potential difference. In the gaps, potential difference is E naught into that distance is D minus T. But I have this gap also, no? No? So here what is the electric field E naught by K? Field reduced by K times. Multiplied by thickness of the dielectric. Thickness of the dielectric is T. Satisfied, no? हाँ समझ में आता है क्या जी? So therefore, if you take E naught common, then what I will get? D minus T plus T by K. Okay, ma? D minus T plus T by K. Okay. So therefore, if I calculate the capacitance of this capacitor, C is equals to Q by V, no ma? So Q divided by, instead of V, what I can write? I can write E naught multiplied by D minus T plus T by K. Okay. And what is E naught? E naught is nothing but sigma by epsilon naught. Sigma is nothing but Q by A into epsilon naught. So take these values and substitute here. Then C is equals to Q by A epsilon naught into D minus T plus T by K. Clear, no ma? So Q and Q gets cancelled. So it is epsilon naught A divided by D minus T plus T by K. Okay, that's it. This is my equation to calculate capacitance when a dielectric of thickness T is introduced. What is meant by T ma here? T means a thickness of the dielectric. Clear, no? So D minus T plus T by K. That is the equation. Have you understood? Okay, ma? Now by looking at this equation, can you say capacitance has increased or decreased? Increased. How can you say? ఏం చెప్తానవరా అది ఎట్లా పోతుంది అది దీనికి ఒకటే కదా ఉండేది సిమా హియర్ ఫ్రమ్ డి వీఆర్ రిమూవింగ్ టీ నో ఫ్రమ్ డి వీఆర్ రిమూవింగ్ టీ అండ్ ఐఎమ్ యాడింగ్ టీ బై కే సో రిమూవ్డ్ వాల్యూ ఇస్ బిగ్గర్ ఆర్ యాడెడ్ వాల్యూ ఇస్ బిగ్గర్ దిస్ is T by K, no ma, very small value. T is a big value. So we are removing huge quantity and we are adding small quantity. It means total capacitance increases. Denominator has reduced, no? Are you able to understand? So therefore what we write? Therefore we write capacitance finally increases. Okay, ma? So if conductor is placed, then also capacitance increases. If a dielectric is placed, then also capacitance increases. Clear, no? Now we will write some cases. Case number 1. Okay? So if dielectric completely fills the gap, between the capacitors. Now can you say, ma? Previously I have placed only T thickness, no? Now this dielectric has completely filled the total gap between the plates of the capacitor. Now what will be the capacitance? Anybody? So now T will become D, no? Thickness of the dielectric will become distance between the plates. Now see what is the calculation. So epsilon naught A divided by D minus D plus D by K. So it is K into epsilon naught A by D, or you can write simply K into C naught. Okay, what is C naught? C naught means C naught ante mane capacitance without any dielectric. If there is no dielectric, then epsilon naught A by D is the capacitance, no ma? Air మాత్రమే ఉన్నప్పుడు లేదా if only vacuum is present, this is the equation. But when dielectric is completely filling the gap, then what is the capacitance I got? I got a capacitance is equals to K into C naught. So what do you understand? Huh? Capacitance increased by K times. ఇది ఆల్రెడీ మనం ప్రీవియస్గా చదువుకున్నాం కదా. Now this is the proof which we have done. Are you able to understand, ma? So if dielectric completely fills the gap, capacitance increases by how many times? K times. That is the point. Clear, no? Now what is this C? This is the capacitance with dielectric. This is the capacitance without dielectric. Okay, so therefore when insulator completely fills the gap, okay ma, then capacitance increases by how many times? Capacitance increases by K times. Okay ma, this is our case number 1. Fine. Now we will write case number 2 also. Okay, case number 2, if many dielectrics are present. Okay ma, it means that, for example, these are the plates of capacitor. Okay ma, consider there are 2 or 3 dielectrics which are arranged like this. So consider there are 3 dielectrics now. Okay, so thickness of one dielectric is T1, thickness of second one is T2, thickness of third one is T3, and total distance between the plates is D. Understood no? Now in this condition, how can I calculate the capacitance? So C is equals to epsilon naught A divided by D minus T1 plus T2 plus T3 plus, okay ma, D minus T plus T by K, no? So T1 by K1 plus T2 by K2 plus T3 by K3. I can write like this. So this will be my equivalent capacitance if many dielectrics are present. Are you able to understand? Direct questions adutadma, so careful ga chudandi. Just substitution of the formula you are supposed to do here. Clear? So totally how many dielectrics? 3 dielectrics are there, no? So T1 plus T2 plus T3. And the next term is T by K, no? So T1 by K1, T2 by K2, T3 by K3. Okay. Case number 3. So case number 3 is, okay, if many dielectrics completely fill the gap between plates. Okay, it means that how can I draw the diagram of this? Clear ma? So this is 1, 2, 3 like this. Okay ma? So this is one dielectric, this is one dielectric, this is one more dielectric, this is another dielectric. Okay ma? So thickness of this one is T1, T2, T3, T4. Dielectric constants are K1, K2, K3, K4. Okay, and total distance between the plates is D. So therefore I can write D is equals to T1 plus T2 plus T3 plus T4. I can write like this. Are you able to understand? Now can you say how can I modify the equation? Deeniki capacitance nenu ela rayachu. Okay ma? See, very simple. Okay, I will write here. So C is equals to epsilon naught A divided by D minus of T1 plus T2 plus T3 plus T4. Huh? D, yes, plus T1 by K1 plus T2 by K2 plus T3 by K3 plus T4 by K4. Okay ma? But here T1 plus T2 plus T3 plus T4 is equal to D, no? So these two will get cancelled. Here and 0 అయిపోతాయి. అంతే కదా? T1 plus T2 plus T3 plus T4 is equal to what? D only. So D minus D, 0. So therefore, what is the final capacitance? Epsilon naught A divided by T1 by K1 plus T2 by K2, and it goes on like this for any number of insulators. Okay, 4 insulators, 10 insulators, 20 insulators, whatever may be the number of insulators, you can use the same formula. Okay, but this is for which condition? A condition lo ide. Dielectrics should completely fill the gap between the plates. Gap undakudadu. Okay, then you can use this condition.